Page 504, we're going to look at topic 8 review. So lesson 1 was on statistical questions. So first of all, statistical question anticipates there will be a variety of answers. So we should have more than one answer here if it's statistical. So the first question is, how many stations are there in a subway system? Okay, by a subway system, they're maybe not real specific here, but assumption we're going to make is that we're talking about a certain subway system. So that if we're just talking about one particular, then that would be not statistical. All right, number 2, how would passengers of a subway system rate the quality of service on a scale of 1 to 10? So if we're asking passengers how they would rate the service, that would be statistical because we're going to get different answers presumably. Okay, we might have some 10s, we might have some 1s. It just depends. We'll probably have some in-betweens. Number 3, how many passengers travel on each of the green, blue, red, and orange lines of the subway system each day? So assumption we're going to make with this is that for each one of these lines, maybe there's a person in charge of telling and figuring out how many people are traveling on each of the lines. So we ask the person in charge of the green line, we ask the person in charge of the blue line, and so on. Presumably we're going to have different amounts of people. It'd be very strange, I think, if we had the exact same number of people on every single line of the subway system. Okay, each line goes through a different part of town, so that would be statistical. Number 4, how much does it cost for a ticket to ride the subway from station A to station B? This one they have as not statistical. Now that could be argued depending on if we're considering if there's different prices for a child or adult. Okay, but if we're not getting that technical into it, or if they don't have different prices for children and adults separate, then that would be not statistical. There would just be one certain cost to go from one certain station to another certain station. Lesson 2, we're looking at mean, median, mode, and range. So we need to remember what these are first of all. So the mean, we add all the numbers and then divide by how many numbers there are. Median is the middle or average of two middles. Okay, remember median, it's almost like medium if you want to say, or like the median in a road, but you got to put the numbers in order first. Mode is the one that happens the most, and then range is a difference between the highest and the lowest numbers. So these problems we're being asked to find the mean, median, mode, and range. It'll take a little bit maybe to work through all of these, so we're just going to look at the first 3 questions. So for number 1, these are already in order, so for finding the mean, they wouldn't have to be in order for the mean, but we can just add these together. If you're doing several things like this, make sure you label them separately so you don't just have a bunch of work and nothing labeled about what you actually did. So we add those up as 12. 12 divided by 3 is 4. So the mean would be 4. The median, these are already in order, so you can see 5 would be the median. We only have one middle number. The mode is the one that happened the most often, if we have one of those, which in this case is 5. And then the range is the highest minus the lowest. Again, even though it's a simple calculation, go ahead and show your work on that. Showing your work to get full credit. Plus, I've seen people make mistakes even on a simple subtraction problem like that before. If we look at number 2, these are not in order yet, so that would be the first thing would be to put those in order. So we've got 2 11s and 3 13s. So for the mean, we're going to add those together first. So if we add these together, we get 61. And then we take 61 divided by 5 is 12.2. If you did it by hand, it'd be 12 1/5. Probably you'd write it as a fraction rather than a decimal doing it by hand. So there's the mean. Again, make sure the mean should be somewhere between the lowest and highest number when you're doing that also. Median would be 13. We just have one middle number here. Mode would be 13. 11 happened twice, but 13 happened more than that. So then the range, 13 minus 11, range is 2. Okay, and then if we look at number 3, 3, once again, we can put these in order first. So 20, 25, 26, 27. So adding those together would be 98. And then 98 divided by 4 is 24.5. If you did it by hand, it'd be 24 2/4, which you can reduce to 24.5. Be the same thing. So that's the mean. For the median, we finally have one that has an even number of numbers, so we actually have to average out those two middle numbers or think about what's halfway between those. So if you add those together, that'd be 51 divided by 2, which is 25.5, or you could just think about what's halfway between 25 and 26. This one actually does not have a mode, so we put none. Remember, mode is the only thing we can have where we can say there is none. And then the range, we would take 27 minus 20, which would be 7. So range is 7. Okay? And again, when you're doing this stuff, this is kind of a mess because I'm trying to fit this all on the screen here, but you know, on your paper, you can use scrap paper and whatever you need to do to make it really organized so there's no question about what's going where. Lesson 3 was on box plots. So number 1, first of all, we would need to put the numbers in order from least to greatest. Once you put them in order, there are 7 numbers, so we have a definite middle number here, which would be 29. Below that, we have 3 numbers, so we have a definite middle number there, which is 27. That would be our first quartile or lower quartile. Above that, we have 3 numbers, so we have a definite middle number above the 29, which is the 31. So 31 would be our third quartile or upper quartile. And then from there, we could draw our box plot. So drawing the box plot, you're going to start from your minimum value, in this case 25. We're going to be going from 25 to 33, so that gives you an idea of what you're working with. We can probably just go by ones on our number line here. Remember, if there's a title or something, or it tells us what the numbers are about, we need to put like under the number line what it's about, what they represent. Above the number line, we can put a title of what's happening. In this case, we really don't know what these numbers are referring to, so we can just go ahead and just draw our box plot out. So box plot should end up looking something like this. Again, each section of the box plot represents about 25% of the data. Number 2, similar idea. This time we have 9 numbers, so put them in order first of all, and we have a definite middle number, which is 3. Below that, we have 4 numbers, so we actually have 2 middle numbers that are below. Okay, again, just looking at the 1, 2, 3, 3 here. So 2 middle numbers are 2 and 3, so we have to average those out. add those and divide by 2, which would be 2.5. And above the 3 we have 4 numbers. 2 middle numbers are 5 and 6. So if we add those and divide those out, is 5.5. So 2.5 would be our first quartile, 5.5 would be our third quartile. We're going from 1 to 7, so we can probably just go by ones again. There's not a big range of numbers here, so just go from 1 to 7 would be sufficient. And notice how a couple of these are right in between. 2.5 would be right in between 2 and 3. 5.5 would be right in between 5 and 6. Lesson 4 talks about frequency tables and histograms. Make sure you can construct your own frequency table. Remember, we talked about splitting up, seeing how many numbers there are, extending that a little bit if you need to. So make sure you can get that all set up for your frequency table first. They went ahead and made their own frequency table here. It's a little bit of a different look because they're going sideways with theirs instead of going down like we normally would. But anyway, it is still a frequency table. What they're asking us to do then on the problem here is they want us to put that information into a histogram. So for your histogram, the first thing you want to do is make sure that you put a title on it. So title in this case we could call Age of Campers. And then think about your highest frequency. Highest frequency was 10, means my bars need to at least be able to go up to 10. We can go past that a little bit if you want. So if you want to go by 2s, and then you can have the in between, means it was in between there, it was an odd number. That's fine. Okay, so number of campers over here, or frequency if you want to call it that. And then at the bottom we are going to put the ages. So age ranges, we're going from 6 to 8, 9 to 11, 12 to 14, and 15 to 17. Remember, with your histogram, you're not going to have spaces between your bars. Your bars will be right next to each other. So for 6 to 8, we had 1 tally mark. Frequency was 1. So that will just go up to the 1. And then the 9 to 11, we had 3. So we'll go up to 3, halfway between the 2 and the 4. 12 to 14, we had 10. And 15 to 17, we had 1. So this is what your histogram should look like. Again, big things that people forget on these is putting titles and putting labels. So that's an easy way to lose points. Again, if your histogram doesn't tell me that information, it's really kind of meaningless to me. I really have no idea what you're even talking about. So make sure you finish off the detail work and put those on your histogram. Lesson 5, first they ask us to find the mean and the MAD for each set of data. The MAD, remember, we didn't compute that. That's going to be something you guys will do next year. Anyway, I'll just briefly show the answers here so you can see what that would have been. The mean would be the first numbers here. Since we've already found means, I'm not going to take time going through that whole process again. Also, the next part on 4 and 5, it asks us to find median, first quartile, third quartile, and IQR. Remember, IQR, interquartile range, that's just the difference between the first and third quartiles. Since we already did median, first quartile, and third quartile back when we talked about box plots, we're not really going to worry about that part of it. One thing we can just mention here briefly is the IQR. So for number 4, if we look at the first quartile is 20, the third quartile is 45. If you subtract those, 25 would be your interquartile range. And then same idea for number 5. 30 minus 13 would be 17, would be the interquartile range for number 5. Lesson 6 and 7 they've got together here, summarizing datas and things. So number 1, they want us to describe the overall shape of the data, include any outliers. So we do have a definite cluster here from 88 to 100, and there's an outlier at 68. That would be a good description there. Number 2, which measure of center and measure of variability best describe the data set. So we can think about, we had an outlier. So since we had an outlier, then the median would be a good choice, and also the interquartile range would be a good choice for measure of variability. So there's a large gap between the outlier and the rest of the data. Again, we already talked about. And then when we use the median, we use the interquartile range rather than the MAD. With the mean, you use the MAD because MAD is mean absolute deviation. Just think of it that way. And then number 3, summarize the data. So just for example, typical number of games sold each week was 96 because that's the median. IQR is 8 games, so about half the time they sold between 90 and 98 games. One other thing going back to number 1 is we could say that this is not symmetric. That's a good description of talking about the shape of it, telling whether it's symmetric or not. So this gives you an idea of what we looked at in topic 8.